Assalamualaikum. In this video, we're going to explain about a case study about application of system of linear equation in strains of bacteria in a test tube. So I'm going to start with an introduction. So what is system of linear equation? System of linear equation is equation that depicts variables in problems that have been solved utilizing some linear algebraic techniques. A system of linear equation can be used to solve practical problems as well as to determine the value of unknowns and also can be applied to solve real-world situations. So our objective in this case study is we need to determine whether the three strains bacteria are three types of food, which is our food A, food B, and food C are exist in the test. And based on that problem, we should find how many bacteria of each strain coexist in the test tube and consume all the foods by writing down the system of linear equation and apply appropriate linear algebra method to solve this problem. So I'm going to present our case study. A biologist has placed three strains of bacteria denoted 1, 2, and 3 in a test tube where they will feed on three different food sources A, B, and C. Each day, 400 units of food A, 600 units of food B, and 600 units of food C are placed in a test tube. The biologists want to know how many bacteria of each strain coexist in the test tube and consume all of the food. So, here is our data on daily food consumption by the bacteria in units per day are as shown in the table given below.
My name is Nur Fatihah and I will explain to you the methodology of our case of study. First, let D be the number of bacteria of strains 1. 2. E be the number of bacteria of strains 2. F be the number of bacteria strains 3. Next, we will write the data from the table as a form of linear equations and we will get D plus 2E equals to 400, 2D plus E plus F equals to 600, D plus E plus 2F equals to 600. After that, we will convert it into a matrix representation form. The method to use to solve the case of study by using Gaussian elimination method. Gaussian elimination method is a procedure for reducing a matrix to row echelon form (REF) by performing elementary row operations (ERO). Step 1. Write the system of linear equations as an augmented matrix and we will get that. Step 2. Perform elementary row operations (EROs) to put the matrix into reduced echelon form (REF) by applying Gaussian elimination method. First step, to make the value in column 1, row 2 and row 3 into 0, row 2 plus with negative 2 multiplied by row 1 and row 3 plus with negative row 1. And the result at row 2, we will get 0, negative 3, 1, negative 200. And the result of row 3, we will get 0, negative 1, 2, 200. Second step, to make the value in column 2, row 2 into leading 1, negative 1 over 3 multiplied by row 2. And the result at row 2, we will get 0, 1, negative 1 over 3, 200 over 3. Third step, to make the value in column 2, row 3 into 0, row 3 plus with row 2. And the result is 0, 0, 5 over 3, 800 over 3. Step 4, to make value in column 3, row 3 into leading 1, 3 over 5 multiplied with row 3. And at row 3, we will get 0, 0, 1, 116. Finally, as seen by leading 1 in every row and a value 0 beneath every leading 1, the augmented matrix has been transformed into row echelon form (REF). Step 3. convert the matrix back into a system of linear equations. We will get the leading variables T, E, and F from the REF matrix. The linear equation that we will get is D plus 2E equals to 400, equation 1. E plus negative 1 over 3F equals to 200 over 3, equation number 2. F equals 116, which is the equation number 3. Step 4. Use back substitution to obtain all the solutions. Substitute F equals to 116 into equation number 2. E plus negative 1 over 3 multiplied by 116 equals to 200 over 3. And we will get E equals to 120. Next, substitute E equals to 120 into equation number 1. And we will get D plus 2 multiplied by 120 equals to 400. And the result, D equals to 116 equals to 116. And finally, we can finalize it as the form of matrix below. D equals to 116, E equals to 120, F equals to 160.
Result and discussion. How many bacteria of each strain coexist in test tube and consume all of the food? Based on methodology, we get strains 1, 160, strains 2 equal to 120, and strains 3 equal to 160. Therefore, the biologist should put 160 numbers of bacteria of strains 1, 120 bacteria, 120 number of strains 2, and 160 number of strains 3 in the test tube if all the food to be consumed. In this case, we are using Gaussian elimination method to find number of bacteria of each strain coexist in the test tube and consume all of the food. Why we choose Gaussian elimination method? It is because Gaussian elimination method is a direct method for solving a system of linear equations. Within a finite number of determined steps, we can solve the given system of linear equation.